Alright. So, this is about the Casimir Effect. Because I heard about this, and I, I, I could be wrong about this, but I feel like this is one of those cases where we're making things more complicated than they need to be. And I think in some ways, the current theory basically is that um, on the outside of these two plates, there's two plates that are put really close together, and on the outside is a vacuum, right? And so it's in like a system that's completely void of other particles, in theory, or about as void as it can get. And so all that should be left in this chamber where these plates are put close together should be basically just vacuum energy or dark energy, right? And so the theory is that there's a greater amount of dark energy on the outside of in between the plates than in between the plates. And so this force of the vacuum energy pushes them together. From my understanding, that's what the current theory is. And I'm kind of confused by this because when I heard about this, I was like, why not gravity though? Why does gravity not work here? And I didn't get a lot of videos looking it up explaining why it wasn't. Basically, someone said that it's because gravity should be too weak to have any effect in this. And I don't think that's true. And I think that the current description being the outside dark energy is greater than the inside is also kind of right at the same time. I think it's wrong, but also kind of right. And I think gravity is the reason why. So my definition of gravity is basically the pull or the flow of space-time, right, into mass. And so when you put these two masses really close together, their mass may be really small, or maybe it's large, I don't know. Maybe gravity shouldn't really have an effect here, but it's not that this mass is pulling on this mass, and so they're pulling each other together. It's that this mass is pulling on the space-time in this tiny little gap between the two, right? So this one's pulling on the space-time from this side, pulling it that way, and this one's on this side of the space-time pulling it that way. And when you put these two plates really close together, you notice this attractive effect, because what's happening is it's not that the two plates are necessarily attracting, but a result of putting two plates close together like that is you've destroyed the kind of gravity equilibrium between these two masses. They're close enough together that space-time cannot replenish fast enough to keep them separated. So they naturally consume all of the space-time in between them until they collide. And electromagnetism, or whatever, is not strong enough to have an effect there. But as soon as they're touching, that's where gravity's strength is too weak, right? Because gravity can't pull atoms into other atoms. So we get this insanely strong pressure in between these two plates, and it seems weird for that to happen, especially in a vacuum. But we get this strong pressure there because there's less and less something in between them. So we get a very attractive force. And so that's what I think it is. And that is gravity. That is not some other weird thing. That's just what gravity is. And so gravity is weak, but when there's a vacuum there, right? Imagine if it wasn't a vacuum and it's just you put two plates really close together. They don't do this, right? They don't get this attractive force. At least I don't believe they do. And the reason why is because when you have gas in the chamber, then you have this pull from the two masses, but there's also gas in between. So it's not going to compress through the gas. The gas is kind of locked into place in between them. It doesn't get pushed out of the way because gas is still mass. It's still a particle. It's atoms, and so these atoms basically get locked in this like chain of pulling in between them, and so the gas basically forms a barrier between these two plates, and so there's no attraction between the plates because the plates aren't actually attracting. It's just the space-time between them is being reduced, and it doesn't get reduced when the gas is filling in the gap, basically, because you can only compress the gas molecules or particles, atoms, so far before they get basically locked into place and create a barrier where neither plate gets closer. And so that distance is basically undetectable. But I would be interested to see how, this is being done on the plates get put really close together. But I would be interested to see what happens when you reduce it not to a vacuum, but make it so that there is maybe 10% the amount of gas in the chamber that only 10% of gas that would normally be in that chamber is left, right? Or make it 1% and see if this effect still happens. See if they still completely pull themselves together, or if there is a barrier that almost forms between them where they move a little bit, but they don't move farther than that. Because if that happens, then that proves it's not vacuum energy, because the gas shouldn't cause vacuum energy that attraction to stop. Because if that attraction is always there, having less of the gas shouldn't make it stop at some point, right? It shouldn't make the force on the outside and be less than what's on the inside matter, because that vacuum energy is always there. So the barrier between them shouldn't matter, unless you're going to tell me that the gas still forms that barrier. But then you ask, why would the gas form that barrier? And you're back to my explanation, I think. So I could be wrong here. There's some aspects of this that I don't necessarily understand. I'm going off of a couple YouTube videos here. But that's what I think. That's what I think the Casimir effect is. And I think we're trying to make it way more complicated than it needs to be for no reason, So that's my thoughts. Peace out.